Hi and welcome to this video about creating a window. I mean, how hard could it be just creating a window, but doing that with the Windows API? So first, a little background. Let's say we have a process, and this process has some threads. Now, some of these threads might create windows, those user interface elements. Let's say thread number 2 creates a bunch of windows. What happens in this case is going to get a message queue. And this message queue is going to be the queue of messages where everything that's happening in those windows would be reported to, which means that thread number 2 here now has the responsibility to pump messages. That is, looking at its message queue and handling all these messages. Otherwise, we'll get to that not responding state that nobody likes. Here's another example. Thread number 1 also has a window, which means it is going to get a message queue, and everything that's happening in that window is going to be landing into that message queue, and thread 1 is responsible for handling all these messages. Otherwise, that particular window is not going to be responding at all. Now, in a typical case, we have a process that might have multiple threads, and usually just one thread has windows, and that's the one that's managing the user interface. This is not mandatory, but this is the most common case indeed. Let's see how to create a window, but before we do that, let's take a look at a tool called WinSpy that I created. This tool is kind of an enhanced version to the Spy++ tool some of you might be familiar with, which is still available as part of the Windows SDK. It doesn't yet cover all the features of Spy++, but it's definitely a good work in progress and has some features Spy++ doesn't have. So first, in this view, you can see the hierarchy of windows. We have the root window here, which is the desktop window, and then we have child windows that are direct children of this particular window, and each one might have their own child windows and so on. If I double click any one of these windows, we can see some properties of these windows, such as the class the window belongs to, and the class is kind of the type that this particular window was templated over. So it's like we can define a class just like a class in an object-oriented sense. We can create multiple instances of windows that are based on that same class and have some common properties, such as some defaults, such as a background brush, for example. So for this particular window, we can see this is in fact the tray that we are familiar with in the taskbar, and doesn't have any particular text. We can see the styles of this window and some other details about the window, and we can also see in this Windows tab some relationship with other windows, such as next window that's part of the same parent, the previous window part of the same parent, the first child window if any, and if this wasn't a top level window, then the actual parent window of this window. So if you go ahead and select some child window here, we can see that in this case we do have some kind of parent window here, which we can click and move over to that other window. So we can look at windows here in any way you see fit, just double clicking and seeing their properties. We can also use this button to enumerate processes and threads that actually create windows. So here you can see some Acrobat process here that has a thread. That thread has a bunch of windows. All these are windows. Some of them are hidden, some of them might be visible. So you can see all that right here. And we can see that same hierarchy as I demonstrated in the slide. So we have a process that might have multiple threads. Some of them might have windows. And these are the actual windows we can look at. And this is how things work in general in Windows. We have processes, threads, and windows as children. You can look here in another example here for Camtasia Recorder. You can see some windows here are definitely visible. And you can see that this window actually has a text and not just an empty text, which is definitely fine. So that's the idea here. Let's see how to do that with something like Visual Studio to create just a single window. We're not asking for much, at least not in this example. So let's start by creating a new project here. And instead of console application, I'm going to use the Windows Desktop Wizard, in fact, to create an application. Let's call that WinApp, just as a good name. And in this case, I'm going to select a desktop application. So I don't want to have a simple main, but I want to see a Win main function, if we can get that working for us. And I'm going to also select an empty project so I can explain every step in the way. And by the way, I could have created a console window, a console application, sorry, and then just change the subsystem to use the GUI subsystem. So we have an empty project, so let's go ahead and create a simple C++ file here and start with that. So let's call that winapp.cpp. So the first thing we need to do is to add some includes. The main one is windows.h. And in fact, that we can start with that and see where that would leave us. So first we have the main function. So the main function is actually called winmain or wwinmain because using Unicode here that expects several parameters. It has a well-known prototype. The first one is an H instance, which represents the address into which the executable is being mapped into this particular process. But most importantly, it's something to use for using various resources that might be part of the project. Then we have another H instance. This is an old parameter called previous instance, which is not used anymore on 32-bit and 64-bit Windows. It's a relic from the 16-bit Windows. And then we have the command line. So we have the command line here, and there's something here called the show command, or the way to show window Windows we're going to create by default. So we have that, and the first thing we want to do is to call create window. But if we try to call the create window function to create an actual window, we can see that the first parameter is the class name. So in fact, we first have to register a new kind of window, a new kind of window class. So I'm going to use this WND class to initialize the defaults for this window, or window type to be more precise. We can then create multiple windows of that type. So there are a bunch of things we can have here, such as the background. So you can do something like HBrush here, which is a way to say we want some kind of default. So there's it's not really something I can explain in detail here, but essentially there's a bunch of standard brushes which are available using these constants of color window or color desktop and things like that. So we're just going to grab that. We can have some default cursor. So you can use load cursor here. And then use a null pointer and IDI cursor. That's the standard cursor really. So the IDC cursor really. That's the standard cursor here that we need to use. And then we also need a basic icon. So again, since we didn't really create any icon just yet, we can use load icon here and just use null because we want to take some of the standard existing icons here called IDI application. In fact, this is not cursor, but error, my bad. It's been a while. Anyway, what are the actual important pieces here? The most important piece, we have actually two important pieces. One of them is the class name. So let's call that my WinApp WND class. That's the string that represents this particular class within this process. And then we need to provide a pointer to a function. That's the window procedure. That's the function that's going to be called every time a message that belongs to one of the windows of this class is going to be is handled by a thread. So let's call that my WND proc just for to make it kind of simple. Then there are some other parameters here like menus and styles and things like that. We can use something like for the style called vReadRow and hReadRow, which just says that if the window changes its size, please send a repaint message, which is a message we'll take a look at. And the other stuff here is not important, so we're going to keep it like the default of 0. Just need to specify the H instance here, and then we can call register class. Register class says to Windows, let's just register this class, and we should get something here called an atom, which is just some number that represents that particular registration. It just needs to be non-zero. Once we have that, we can move over to the next step, which is indeed finally creating the window. So let's create the window. First, we have the window class. So let's just copy the window class here. And then we have some style. I'm going to use overlapped window. This is a style for the window, not for the class. So overlapped window is in fact a bunch of styles. We can press F12 to see that. That means like a top level window, a typical one that has a caption, a system menu on the left. It's resizable. It has a minimize box and maximize box. That's going to be good enough for our purposes here. The next parameter is a bunch of numbers to get us to provide, well, we have the window name here, which I missed. Let's call that my WinApp application. This is just the title bar, really. So now we need to provide a position X and Y and a size for this window. If we don't want to specify something specific, we can use something called CW user default, which tells Windows, please just figure it out on your own, don't really care, just create it somewhere with some size. Since it is resizable, we can go ahead and get away with that. But if you want something more specific, you can definitely do that by specifying something more specific. Then we have a parent window, which we don't have here. It's going to be a top level window, and there's no menu at this point, and the instance is going to be something coming from that H instance that we have. And the last parameter is the parameter we can pass to the window procedure. In this case, I'm not going to use that. So if that doesn't work for some reason, then obviously we can't move any further. We can return some error from main, just as a simple example. Once we have a handle to window, what's next? So the first thing we'd like to do perhaps is to show the window. So we can show the window by calling the show window API and use the show default value, which will just use the value coming from the command show here, which usually is show normal, which means that it will be shown not minimized, not maximized by like normal window. And then we can call the update window function, which is optional, to say let's just send the paint message to the window immediately so that the client rectangle can be updated as soon as possible once the window is shown. Okay, so what's next? The next thing to do is to pump messages, because remember, this thread is now the owner of that window, and any other windows that might be created by that thread later on or even right now, then we have to pump messages. Otherwise, we'll get the UI to be completely frozen. So for that, we can use the following kind of loop. There's a structure called MSG, which represents messages coming to Windows. What we're going to do here, we're going to use the getMessage API. GetMessage says, please wait until a message is available and then bring that message back to me. So the message address is passed here. Null here indicates that we don't really care which window that message is pointed to. And then we can also kind of filter here the range of messages. In this case, we're saying we're just going to accept all messages. And the simplest thing to do is to call the function dispatch message. This function is indeed dispatching the message to the appropriate window procedure based on the handle to window, which is stored within that message. So if this is going to be this window, and it has to be, then in this particular example, it will call my WMDproc, which of course we have yet to write. And sometimes there's another call here called translate message, which translates certain keyboard combinations into different messages. For example, if you use something like Alt F4, it will change that to WM close message rather than just give you a keyboard message of Alt and F4. So this is typical, something that is typical to do. So we'll do that. So getMessage is a blocking function. It doesn't return until there is actually a message. In that case, it returns true and the message is here inside the structure. The only time it returns false is when the particular message is something called WM quit, which is a typical way to break out of this loop. Otherwise, it's going to be an infinite loop. Once we're done, we can just go ahead and return 0 because it means we should be probably quitting. We got a WM quit message. So with that, we have our basic code for creating the window, but that of course is not enough. We have to have that window procedure. And that window procedure has the following prototype. It returns a L result, which is just an integer. The callback macro, just like the Window API macro, is just std call, which is important for 32-bit because the calling convention there is important. So there are many macros that mean exactly the same thing. So I want to give that name my WMDproc, and this is where we expect to receive the main parameters for a message. Essentially, that's the 4 first members of a message structure, which is just going to be kind of decomposed here and provided as separate values. So we have here the handle to window, this is targeting, the actual message, and we have 2 message dependent parameters which are called wparam and lparam. In the old days, one was a word 16-bit and the other one was 32-bit, but now they're both 64-bit in a 64-bit process, but the names just remain for compatibility reasons. So what we typically do here is have some kind of switch over the message that we get. We want to handle what we know of, and what we don't, we want to return and well, send that to some default processing. There's a function for that called def window proc. So anything we don't handle want to send to some default processing, because this is important. Windows knows how to handle many kinds of messages automatically, such as closing messages and things like that. So let's just do that so we don't break any basic functionality. So now all we have to do is take care of several messages. I'm going to use two messages here. The first one is WM destroy. WM destroy is when you destroy a window, such as hitting the X button to close the window, and then it's going to get two messages, WM close, and if we don't handle that, by default WM destroy is going to be sent to the window just before the window is actually destroyed. So this is where, since this is the main window in our application, and it's also the only one in this example, we're just going to call the function post quit message, which is going to post a WM quit message to the application here. And so we can do that, and that would well, essentially would cause our get message loop here to break. So we can exit the application, otherwise the window will be destroyed, but the process will be very much alive. So at this point we should have something that is working. Let's see if that works. I mean, maybe there's some kind of bug here, is definitely possible. So let's press F5 to run this with the debugger and hope for the best. So here goes, apparently it worked. We do have a window here. And if I go ahead and press the close button, we can see that Visual Studio indeed the debugger is out and the process is down. So that's nice. Let's do another thing here to make it a bit more interesting. Let's add a message for WM Paint. WM Paint is a way to say, hey, here's your window. Please paint the client area with something that is meaningful for your application. Okay, so what we're going to do here is to use the classic GDI, the graphics device interface, to get a device context. And the way to do that is to use the begin paint function. We're going to give it the handle to window and also a structure called paint struct. So we just need to create one of those. And then we can go ahead and draw whatever we want. And then once we're done, we're going to do end paint here, provide the handle to window and the paint struct. So we can do the drawing here, but let's just use draw here. And well, let's just go ahead and draw something very simple, such as, say, an ellipse. So the first thing I'm going to do is to look at the size of the client area by calling this function getClientRect, getting the size of the client rectangle using a rect structure, which is a very simple one, having a left top and then right bottom kind of members. And then I'm going to use the ellipse function. So this one accepts device context. This is the kind of the way we paint in GDI. This is kind of the surface to be painted on. That's the abstraction that is provided, called the device context. In this case, this device context is going to draw on the window. And then we have some parameters here, as you can see, left, top, right, and bottom. So we're going to start with the top left corner and use RC right and RC bottom here as parameters. That should be good enough to get us some very simple ellipse here. Let's see. Pressing F5 again, here's our ellipse. And you notice that every time I resize the window, the ellipse gets in fact redrawn. It gets redrawn because of the style saying CS_redraw and CS_vdraw, which we put in the WMD class when creating the window class, that says every time the window size changes, please issue another WM Paint message. And in fact, every time I do any kind of change here, the WM Paint message is continuously being sent to the window, and we're handling that in the appropriate way. And since we're calling getClientRect, we actually get the correct size of the rectangle of the client at that point in time, which makes our ellipse kind of perfect in that respect. Of course, we didn't specify any kind of color or anything like that. We're just using the default, which is using this black pen, but there are of course many ways to customize that, but this is beyond the scope of this video. So there you go. We have just a single window created here, and it took us only about 30 lines of code or so. Even if I disregard WM Paint part, it does require some work, but once you get the hang of it, it's probably not too difficult. But that's kind of to give you an idea of what that thing looks like. Here's another very quick example before we end this video. If I go ahead and create another window, I can just do that. I'm using the same class, which means I want the same type of window, but it's a distinct window. Let's give it a different title, like a Windows Application 2 or something. And we can, of course, show the window, which we definitely want to do, or we can also add the WS visible style here if we wanted to. And that would not require us to use show window, but of course the update might not be immediate, but it probably won't be actually visible. So here's one window, here's the second one. So you can see we have both of these titles, and these windows have the same behavior because their type is the same. They're part of the same window class. They're built around the same template, but of course each one is a separate instance. Each one has its own size, its own handle to window, and is drawn independently. But all the messages for both of these windows are coming to the same message queue that is used by that particular thread. By the way, we can go back to WinSpy here, and then let's go ahead and create another one of these to refresh the display. And you should find this Win something here somewhere. So here's, let's see what that is. Should be called the Win application or my Win application or something. Let's see, where is that? Okay, so here's a Win app. You can see we have a single thread here, and we have two top level windows here. We have this one. You can see all the style of that window. Here's the text. Same goes with this one. We can see its own text, and it has its own rectangle, of course, and own handle. And there's some other hidden windows here that were created by other entities, such as related to COM, things like that, which we are not here to discuss. But you can see these two windows right here, right below this specific thread, which is our thread that we just created.